So welcome to this talk. Interesting to see if it's what you expect. So my name is Steve Poole. I work for Sonatype. I'm a developer advocate. And what I care about is helping Java developers and other developers create safer software and thinking and looking at things from a security point of view. Deep background in the JVM, worked for IBM, all sorts of stuff. It's great, loads of stuff, loads of background in the Java community, but the passion right now is how do we get developers to focus on improving their security posture, getting people to think about it. And that's what this talk is about. We're going to sort of dip through some of these things so you have a sense of what's going on. Because believe me, the future requires us as developers standing up to responsibilities that you may not even be aware that you had. Right? And I'm going to pull out what some of those are and try and get you to start thinking differently. So the title of this thing is Log4J, or Log4J is in the title, of course. Log4Shell. Who heard of Log4Shell? Yes, I'd be surprised if you didn't put your hand up, right? It's considered to be, right now, probably the worst vulnerability, at least that we know of, ever, because it's so easy to manipulate. Right. So let's talk about why that is. So you know Log4J is about logging. It's a debug tool for developers. So it's about taking code, it's about recording data that comes into your system so that you can trace where your application went, which path did it go down. So you have a vested interest to make sure that whatever you log, however you log it, it's as is, untouched. Because if the data is different in the log, you won't know which way the code went. And the obvious thing is you're trying to figure out which path you went down. So it's all about logging as is. That's the first thing. The second thing is Log4J started off as basically that, a nice way of getting information that we cared about into a log so that we could use it. But it has grown. Over the years, it has grown. And one of the ways it's grown is by these things called lookups or substitution parameters. And they're a reasonable thing to add, because there are times when you want to record what JVM version you're running on or what OS you've got, because that may be important to your application. Your code may be being used by multiple people. You want to know what your environment is. So there's all sorts of ways of getting at important environmental information. And in fact, there's all sorts of stuff that's easy, because it's safer as a developer to rely on these special properties to be in the logging than it is for you to try and do yourself. Right? And obviously, it saves effort, but it's generally safer. So we've got logging data as is and all these wonderful lookup properties. Yeah? And you know that these things came together when in 2014, a new one was added, which was the JNDI thing. So you know about, the fact that people were trying to just basically insert data that look like those system lookup things. It gets down to Log4J, and Log4J interprets it and does exactly what it says. Well, that's how it works. And this thing came in, and nobody thought any more about it. It sounded like a good idea. There is data, there's more configuration data in JNDI that people want to get access to. It fits in with the design. But people didn't check that pulling in JNDI also pulled in LDAP and RMI and DNS. As developers, we focused on that being, all these wonderful capabilities being great for us as developer, but then they got exploited, right? Because we created something for our benefit without thinking about the security context, because we are not educated, we're not aware. We just went, this is really cool for us, makes life easy, and we got excited. We added stuff, we have stuff, right? And then we add bad guys, 4 days after it went public, pretty much everybody was being attacked because it's trivial. All you have to do is get the right string into some piece of into the system, whether it's in a header or a cookie, or it's a database field, or it's the name of your car if you've got a Tesla, or your iPhone address. In fact, there are still people out there with Twitter handles, which are bad news if you've got an application that logs them, because they've got $LDAP on them, right? Easy. They were just straight in there. Right? And it's not bad enough that they were being exploited. So we created something that we didn't think about consequences because we didn't realize. The bad guys turn up and exploit it because they understand how easy this stuff is. And then when we as a community try and address it, well, a year later, the numbers don't change now, but a year later, almost a year later, the number of people downloading vulnerable versions of Log4J is still in the 30% range. So Sonatype runs Maven Central. We can see the downloads. So 30% of public downloads from Maven Central are still vulnerable versions of Log4J. That's our problem too, because somewhere in this pipeline, we're not paying attention. Right. So we as developers are mostly culpable for being excited and adding things and not thinking about the security issues. And our IT organizations are culpable because they're not thinking really about how good the tools are they're using. Nobody actually tests this stuff. It's all tick marks. Right? And that's not good anymore, right? May have been good once, definitely not good now. Because the only thing between your application and the bad guys is software. And we've just demonstrated just how good we are at thinking about security from a software point of view. None of you got here in this room without software being involved. I can't present without software, obviously. The lights can't be on without software. You know, your car doesn't start without software. Think about that. Think about our attention to detail and the fact that software is everywhere. Right. So, we're not very good at this. We occasionally do something like Log4J that is just very fantastic gift for the bad guys. And of course, they use it. When I first started talking about cybercrime, 2015, 2016, the amount of money that the bad guys got out of it was about the same as the drug trade, the illicit drug trade, right? And you know all about how big the illicit drug trade is. You know all that. $450 billion a year-ish, right? And if you want to turn that into different numbers, that's $14,000 a second, or the same amount of money to buy 50 aircraft carriers. And it turns out that actually right now there's less than 50 in existence. Okay. Oh, come on. That was 2016. 2022. Okay, so do you think the number's gone up? Anybody thinks the number's gone down? Yeah, okay. It's not about going up, it's about how much, isn't it? Well, look, here we are. Okay. 6 trillion. It gets to the point where it's almost unmeasurable. 620 carriers. And I had no idea where you'd park 620 aircraft carriers. And I worked out today that these all have about 80 jet fighters. So it's space for 50,000 jet fighters. That's fun. Let me put it in a different way. If cybercrime was a country, $6 trillion would make it the 3rd largest country in the world. So think about that. Think how serious that is. Think how much effort we put to deal with the drug trade, and now think about the fact that cybercrime is way past that, and there is no sign of it stopping. Right? It's like it's just growing at like 56% per year, per year, per year. It is. And why is this? Because the 2 technical groups that are involved in solving this problem, that us as developers and us as IT guys don't really understand what they've got to do. This is why developers, like us, are actually on the front line of all this, but we don't really realize that. Okay. Look, the bad guys, they do all the things they used to do. Right? You can still find botnets trying to get into your systems. There's all sorts of bad ways, and you would have read about this stuff. You know, they want to ransom, they want to do ransomware, they want to steal your CPU to do Bitcoin mining. Any way they can get into your systems and make use of it, they're going to do. And that's been going on forever. It's just a matter of magnitude. But now we have new stuff. Now we have people targeting open source projects, specifically trying to add stuff into open source projects, trying to compromise human beings, trying to get into build systems. You know, it's long-term things. This is new goals, and you'll see why in a second, right? When you're targeting people for money, you have one motivation, and if it's hard to do, you may move on, because you can go somewhere else and do something for easier. But we don't have that. We have this other thing now. We have this thing called cyber warfare. In the last year, 18 months, it's now become very visible that this is actually happening, and it's actually happening in ways that wasn't even predicted. Right? But if you thought it was bad enough that you had people trying to get into your systems for a profit, now they're trying to get into your systems to take control. Right? Different breed of attacker, much more persistent, much more educated. They're trying to get into your systems for different reasons. Right? They're trying to get into the supply chain. Now, we're all part of a supply chain. We're, as individuals, as companies, the supply chain might be just your source code to deployment. That's a supply chain. It might be that you're offering a cloud service and there's somebody else is consuming it. You may be selling software. We're all part of supply chains, right? Any business we're in is part of a supply chain. And the bad guys want to get into those supply chains, whether they're software driven or whether they're for software or whether they're for a business or whatever. They want to get into everything they can. They want to get into your power systems. They want to get into your train software. They want to get into your supermarket delivery systems. You know, forget, ammunition and stuff like that. No, this is just straightforward getting into the things that control the behavior of your country and your economic position, all that sort of stuff. Because at some point, they want to pull the plug, right? Because it's so easy, so many people are trying to do it. So every nation state you can think of, don't just go, oh, it's the Russians or the Chinese. No, everybody's doing this. This is the new way of the world, because software is so easy to get in and do these things, right? And there are loads of examples of them doing this. Unfortunately, it's even worse than them getting to the point where they're positioning to make use of it in some future war. What we're seeing now is that they're actually making use of that capability right now. It turns out it's very easy to affect your economy. You know, we're not talking about fake news, though that's part of this conversation. It's just what happens if we just screw up your supermarket deliveries? What happens if your things don't get delivered? What happens if the train signals stop working? It just impacts your economy. And they are trying these things out because obviously they want to prove they work. So you'll see these happening more often, but it's more than that. It now becomes an effective weapon to reduce your capabilities. It's going to go on forever. Because right now, we as software developers and the IT guys we work with have yet to have an effective defense against this, right? And it's here forever, right? Because Sonotype is in the security space, we keep track of what types of attack happen and how they happen and stuff like that. And in the last couple of years, what's called supply chain attacks have grown, well, there you go, a large number. the type of attack, getting into supply chains for these purposes has become the new growth industry in the cyberspace. Okay. Now, this is every year we release this state of the supply chain thing, so you can go see more details, but you get the idea. Things aren't going great. And other aspects of this, because there is some good news at the end of this, but I want you to understand what's really happening. So when vulnerabilities get reported, if you're lucky, there's time between when it's reported to when it's exploited. And way back, 2006, you had heady amount of 45 days from something like Log4J being reported before somebody would try and attack you. Well, you can see that when we got down for Log4J, well, it'd been out since 2014. So actually, the new reality is exploit before publication. As soon as you hear about a major vulnerability, it's too late. People are using it. So that means the way that your operations team work, the way that you work, in terms of dealing with these things, has to be as automated as you can make it. You need to be able to get in there and fix these things as soon as possible, because you have zero time. Okay? And you know what? It's even worse than that. Because these vulnerabilities, these major vulnerabilities, for which there are many people looking for them, now get paid not to report them. We have instances of many millions of dollars exchanging hands to suppress vulnerabilities because they are so useful to nation states to compromise people's systems, let alone make money. Okay? So that means this. That means every piece of software that you're relying on is now a potential target vector for the bad guys. Whether it's on your phone, whether it's the systems in your Raspberry Pi, whether it's your software in your kids' toys, they are all potential vectors because they're trying to get into your systems, right? Got some more good news? I haven't got any more good news. I got more bad news. They are way past the idea of looking for vulnerabilities. It used to be that they would just wait for vulnerabilities to be discovered. No, no, no. Now, because of the motivations, the money, they're making their own. There's a whole set of classifications of these types of problems, and I won't go through them, but basically, they're trying to compromise open source projects, to get in there and compromise them in all sorts of ways. Sometimes it's really simple. Can I get into your build system? And that bit at the end where you package it up, can I add some malware? Or it might actually be, can I actually change your source code to reduce some of the authentication checking, or it just depends, right? And the open source is the primary target because 90% of the applications that we construct are made up of open source, i.e. most of the software that you ship, you didn't write. 5% of those on Maven Central have these sorts of vulnerabilities. That's the ones we know about. Right? So there we are, right? Not good. We have much more targeted, much more motivated people trying to get into our systems. Okay. Now, the good news is that finally we're beginning to do things about it. A couple of years ago, I can't believe it's a couple of years ago, last year, the US government finally realized that they had to do something. Large number of big meetings with very large companies. Actually, Sonatype went there as well, which surprised me, but Google, IBM, Microsoft, you know, people get it going. What do we do? What's the most effective things that we can do? And they started by going, well, actually, the very first thing we should do is recognize we have this problem. Let's start to mobilize this. And you will see, as the years progress, more and more about this. You will see the terms. You'll hear about supply chain. That'll be coming up more and more and more, right? And they're starting to realize that the best way to get people to pay attention, given that we haven't so far, is to apply pressure to the businesses. Make it a business problem, and hopefully that will try and to track it. So eventually, there are dates like 2024, 2025, where you won't be able to sell software to the US government unless you've got all the right ticks in the right places. And I'll talk about that in a sec. Right? It is going to change the way that we build software. It is going to change the way we can consume software. There's lots of things coming down which have words like automatic and evidence and chains. You think of the build processes that you've got. You think of the build processes that a lot of the open source projects have. Very simple, very lightweight. Well, that's going to have to change because you need to have secure build systems with proof. And one of the things you're going to hear about is SBOMs. There's a couple of talks this week about SBOMs, software bill of materials. Again, I could go into details, but you can go read about this stuff. But it becomes a thing that you have to produce. It's a signed list of ingredients that goes in your software. And every open source project that you consume will have to provide one for you, or you'll have to provide it to the government. It all starts to get heavy. So it says the way that we build software is going to change. But as developers, we now have not only the responsibility to wake up and go, am I writing software in a correct way? Do I understand about how to create safe software? 90% of your application isn't written by you. So what do you do to choose software that reduces the risks? Up to now, what do we choose software for? We choose it based on, does it do something that I want? And then maybe on the license. You know, but that's probably it. Maybe your business has a say in it, but not very much. We're using Spring. Okay, they are done, right? Is it any good? Is it safe, secure? Don't know. Right? So now you have to think about the consequences of pulling in something that is not a very good open source project, that has poor behavior in how they develop. And these are going to become parts of the equation when you select software, right? Will they be able to fix something if you find a problem? And you think about our relationship with open source projects. We're here in this wonderful EclipseCon. There's all these open source projects. What contract do you have, any of them, that they will fix a bug that you report? And the simple answer is you don't. You have a contract with some vendor, and then you think of all these other open source that you're using. What happens if one day a vulnerability turns up and one of those guys goes, I can't fix it. I don't want to fix it. What are you going to do? Because you're now compromised. So this is all starting to go through people's heads. And as a fact, and therefore, from Linux Foundation down, there's a lot of money being chucked in the top now, and it's starting to filter down. We have lots of people beginning to think very seriously about how we do this. So lots of assessment tools are coming out. Some have been around for a bit and are growing, and new ones are being created. And they are trying to work out how you quantify an open source project's behavior. Well, they're trying to work out how well can you analyze source code to look for security vulnerabilities. These things have been academic before, now they're becoming more mainstream. And you'll see AI applied to this, of course, trying to figure out whether we can do this. But it ends up coming down to you so that when you choose some software, it isn't just, oh, I've got a binary and it does what I want. I've got a binary that I want to choose. It's got some known vulnerabilities. It's got some scorecard about its behavior. It's got some scorecard about its approach to security, etc. And those things are what's coming down. Now, Sonatype is doing its own thing in its own way. We're looking at those. We are going to take as much of this information as we can and put it on Maven Central so you can see it. But we also have our own ideas of what makes sense, right? And so we're exploring all these things. This is a thing called Bomb Doctor, which you can go find. This one lets you look at all your dependencies, and it scores them based on some criteria that we have, and it tells you whether your dependencies are good or bad, right? That's just one way of doing it, but you can see where we're going, right? So that sounds all great, but those things are taking time. So if there's one takeaway from all of this, there's one takeaway from all of this, You as a developer have got to change the way that you think about software. You've certainly got to learn more about security, but you've got to start looking much more critically at the software that's part of your stack, the open source projects that you consume. Some really simple things you can do, but mostly it's starting to be critical, right? Do they have basic stuff? Like, do they have license files? Do they have a security MD file? You know, do they tell you how to report vulnerabilities? A lot of them don't. So if they don't tell you how they do that, do they do it at all? Right? And you can see these, you know, like build processes. What are the classic ways of the bad guys getting into an open source project? It's got nothing to do with the code. They just compromise the build process. Hey, here's a GitHub action that does some stuff. Please use me. Loads of people do that. And at the end of the GitHub action, where it does, I'll package things up for you, add in some malware. Hey, you didn't notice because you were using something that was easy to use. You need to start thinking about that from a cynical, world-weary point of view. Right? And there are, you know, other things to look for. It isn't just have they got the right files. It's like, what would make you suspicious? Now, you know, as a developer, that when you produce code, sometimes you don't get the quality right, and sometimes you build more often than you expect, and you have your own signs of what you know means it didn't work too well. You start applying those to other people's projects. You start thinking about, is this thing safe to use? Are the people who are producing this, do they know what they're doing? Because if they don't, then you're taking a risk. And that's really, you know, the takeaway here is the world that you knew, that wonderful world we had of open source being this fabulous group of people we could trust and all work together, is being compromised. The same people here, everybody is the same people, but there are bad guys coming in, they're exploiting our weaknesses, they're exploiting the fact that we're not paying attention, and they're trying to compromise our systems. And they're doing it for an enormous amount of money, but that's beside the point. They're doing this because it's possible. And you have all these nation states who understand just how much damage they can cause to the others, because we as developers and our IT guys haven't got our heads around how to fix this yet, right? So I'm sort of back to that first slide, and it's like, we as developers have got to change our spots, right? We've got to take more ownership of this problem. And I, like many of you, will go, well, security is not my problem. It's a DevSecOps. I'm the dev guys, and there are these security guys. It's not good enough, right? You as developers have your own responsibilities towards making sure this problem doesn't get any worse and that you can do things better. It isn't really hard. It's just waking up to thinking that way, because if you don't fix this, nobody else will. Because the ops guys just rely on the tools that they buy. They don't understand how classes can be hidden in jar files, what magic stuff can happen. But you do. And you understand how development works, and you understand what developers could do to hack things, because you've probably done it yourself. Right? So there we go. Do you think you can change your spots? Okay, I'm done. Any questions? No, you're scared. Thank you. No questions? Okay. Well, there we are. I'm here. When is the end? Tomorrow? Tomorrow, yes, so tomorrow. Come and ask me questions. Thank you for sitting here and being scared by me. All I can tell you is it's up to you to fix this. And I hope you go away and think about it. Yes? Can you have a mic? I can chuck one at you. Yeah, I'll repeat the question.
So, I've been working with SPOMs and I've been hearing it like every other day. The software bill of materials.
Yeah.
And so Renovate, Sona type live, Salsa, everything, they have their own type of bill of materials. So do you think, is there a standard of, do you think it should be standardized?
Okay, right. Okay, right. So what you're really asking is, are there standards for SBOMs? Okay. Who has heard of SBOM? Okay. Does anybody know what an SBOM is? Okay. So SBOMs, it's a bill of materials. It is exactly like it says it is. It's like the ingredients on the side of the can. And there are at least 2 standards. There's one called Cyclone DX. I don't think I have a picture of that. Did that one on there? No, you can't see it. Okay. There are 2. There's one called Cyclone DX, which is an XML-based one, which is specifically designed to be an SBOM. XML file tags that for the different types of dependency you have. There's also one by SPDX, who you may recognize the guys who did the license file management things. They have SPDX 3.0, which is almost out. That is also a standard for SBOMs. Both of those are part of this thing. Yes, whichever way you want. Your picture of Joe? Yeah. But basically, the SBOM part of that, they've said it's one of these 2 specs. And in fact, there are others as well. Okay, so that's, yeah. So and if you want to play one, so since I'm talking about it, we have this thing called Bomb Doctor, which was this picture here. You can go to bombdoctor.sonatype.com and you can upload, you can generate your own SBOM. There's details. You can use Maven with the Cyclone DX plugin. You can generate an SBOM. You can load it to this website and you can navigate through and see what your dependency tree looks like and see whether you've got any vulnerabilities already, or you can go play with the ones already up there. Right? But yeah, it's definitely get your head around what an SBOM is. It's not a complete panacea, but it's a lot better than what we have at the moment, which is lots of dependencies on scanning tools to find out what you've got installed. And that then depends on whether the scanning tool you've bought is any good and whether the data it's using is any good. Whereas SBOMs help you around that problem. Any more? Good. I'm so glad when the audience is, oh, you scared me. Anyway, thank you very much for listening, and I'm around until Thursday. Yeah.